Hi and welcome to this video. I am going to be working through and showing you the work solutions to the 2023 Edexcel IGCSE 1H November paper, as you can see on the screen in front of you. Now, I have time-stamped each question, so you should, if I've done it properly, be able to jump to exactly which question you need to see the solution for that. And this is going to be a series of videos I'm going to be running in the lead up to the IGCSE exams, just talking through the past papers, doing as many of them as I can for you. Without further ado, let's get stuck into it, going through each question one by one. Okay, now the first question, if I scroll down, we've obviously got the formula sheet. We may need that at some point, but to be honest with you, I can remember most of the formulas, so probably won't need to come back to that. But for you, if you've got the paper in front of you, do make sure you use it. It's there for your use. Right, so this first one is about set notation and Venn diagrams, really, and it's pretty straightforward. It's all about finding certain things in certain sets. So here we've got list the members of the set A. That's going to be all the things inside the circle A, and that includes where they cross over. So it's everything inside of there. And you don't have to put these numbers in order, because actually with set notation you think of these as kind of like items or things rather than you know, what they are, which is numbers. So you don't have to put them in order, you don't have to worry about that. So here is 5, 7, 9, 11, 13 and 15, and just make sure, one way to make sure is to count the numbers 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I've got them all. Okay, now the next question is, and I'm just going to say sometimes my head might get in the way, but I'll make sure to check and get it out of the way so you can see the question if you need to. The next question is A intersection B. Now if we go back up to the diagram, that will be where A and B are satisfied or cross over. So it's this bit here. Okay, now that is just 5 and 15. So go back down. 5 and 15, and that's only 1 mark question, so you have to get the answer right to get the marks there. There's no marks for working out. Now this is not, and that's what this apostrophe symbol means, not A or B. Now A or B, the U, the U symbol looks like a U, it actually stands for union. That means or, okay? So what this means is we've got A or B in the brackets, and then this apostrophe, that means not. Okay, so it's not A or B. Now A or B would be anything in A, so anything here, and anything in B. So anything in A or B there would be A union B. We want the opposite of that, called the complement, which again means not A or B. So it's going to be all the numbers outside. So it's going to be 6, 8, 12, 14, 16. I can write 16. I'll write that again. There we go. Okay, so it's actually all of the outside of that shaded section. Okay, so that's the answers to the first question. Question 2. 2 part A is what I would call a standard factorising question. Now it's not a quadratic. We don't have the highest power being squared, so we're not going to have 2 brackets normally for something that doesn't have, well, ever actually, highest power of 1 in this case. We've got p to the power 1, q to the power 1. So we look at our numbers first, 12 and 18. You could think of it as minus 18 if you like, but I'm just going to think of it as positive for the moment. 12 and 18. Biggest number that goes into both of those is 6, so that is going to go outside the brackets. And then we have got, in terms of the letters, there's P in both, so we can put that P outside. We can divide both of the terms. This is one term, this is a second term. We can divide both of those terms by P, so that goes outside of our bracket. And then the first term has a Q in it, but the second doesn't, so we can't divide both terms by Q. So now we put our bracket in, And if it's a minus in the middle, like in this case it is, we are going to put a minus in the middle of our two terms in the bracket. And then we've got to think about what we times 6p by to get 12pq. Well, 6 times 2 is 12, p times 1 is p, so that's fine. And then we need to times it by q, so it's going to be 2q minus, and then 6 times 3 is 18, and we've already got the p. So that's done. Move on to the next part. And this is a worded question. So we've got 56, scroll it down a bit, get it to the right part. There we go, that's better. 56 metal bars in a box. Each metal bar is gold or silver or zinc. Y metal bars are gold. 3y plus 7 metal bars are silver. 2y minus 5 metal bars are zinc. Work out the number of metal bars that are zinc. So we are told there are 56 metal bars in total. So we're going to do y, add 3y plus 7, add 2y minus 5 is equal to 56. We're going to collect the like terms. We're going to simplify that. So that's going to give us 6y in total. We've got 1y. If there's no number, that means the coefficient is 1. So 1y, add 3y, add 2y, 6y. 7 minus 5 gives us 2. You have to include the operation before the number. Okay, so we have to do 7 minus 5. That gives us the 2, and that's equal to 56. Then on both sides of that equation, we are going to subtract 2. Change the size of that. That gives us 6y is equal to 54. Okay, now from there, we are going to divide both sides by 6. And that will give us y is equal to 54 divided by 6 is 9. Okay, now that isn't the final answer because it asks us to work out the number of metal bars that are zinc. Okay, and it says to show clear algebraic working, so we have to make sure we do that. Now, zinc is 2y minus 5. Okay, so we are going to do, to get our final answer, 2 times y, which is 9, minus 5 gives us 2 times 9 is 18, minus 5 is 13. Okay, I'll just scroll that down so you can see that. There we go. So that's our final answer, 13. Okay, right, moving on to the next question, question 3. Joshua buys a car for $12,500. He sells the car to Nina. Nina pays a deposit of $1,500, followed by 36 monthly payments of $450. Work out Joshua's percentage profit. Okay. Now, first thing we need to do here is work out the total that Nina is paying. So she is going to pay $1,500 plus 36 times by 450. Okay, now if we put that into our calculator, 36 times 450, we get $17,700. Now we need to work out Joshua's percentage profit. Now, to work out percentage change or percentage profit or percentage decrease, what you do is you take your new amount, so 17,700, you subtract the original amount, 12,500, we divide by the original, so you're working out your change on the top, the numerator is the change, over the original, 12,500. Now that, if we put it into our calculator, will give us the answer as a decimal. We need it as a percentage, so we want to times that by 100, and that will give us our answer. Okay, now I'm just going to put that into the calculator very quickly and see what we get. So 17,700 minus 12,500 divided by 12,500 times by 100 is 41.6%. Okay, now if we notice in the question, it doesn't say to round that to anything, and we've got an exact answer there, which gives me more confidence that it's right. If I got something that was a repeated decimal and it doesn't say, like it doesn't in this question, about rounding it to a specific number of decimal places, I would want to just double check that what I've done is correct. Now, one way of checking this, if you were unsure, although it's a fairly routine procedure, is to do 41.6% of 12,500 and add it on. So if we did that, 41.6% times by, or 41.6% of 12,500, a way to do that is type in 0.416, because that is changing your percentage to a decimal, times by 12,500 gives us 5,200, which when we add it on gives us that 17,700. So we know we are correct there. Okay, so that's fairly straightforward. Moving on to question 4, we have got, again, what I would see, or what looks to be a fairly standard problem here. So we've got a bias spinner. Okay, so there's not an equal chance of landing on each of the possible things, blue, orange and white. Has 3 sections, each of a different colour, as we just said, blue, orange and white. The table shows the probability that when the spinner is spun once, it will land on blue or on orange or on white. Work out the value of x. Now, what we know and what we always have with probabilities is that all of the outcomes will add up to 1. So if we do 0.58 plus 2x plus x, that has to be equal to 1. Now from there, we are going to collect our like terms. So 0.58 plus 3x is equal to 1. We are going to subtract from both sides the 0.58. Okay, that will give us 3x is equal to 0.42, if I've done that correctly in my head, which I should have done. Double check on the calculator. It is a calculator paper. Always make sure to utilize that and not try and do too many things, or anything that you can do on the calculator, do it on the calculator, because you don't want to make careless mistakes through trying to do things in your head. Because when people are marking these, they are not going to care whether you've done this in your head or not. They just care whether you've written down your working out, got the correct method, got the correct answer. Now we are then going to divide that by 3 on both sides to get a value for x, which is going to give us 0.14. So that is our answer for x. What it would be a good idea to do now, before we even read the next part of the question, is to fill in the probabilities for orange and white. Now white is fairly straightforward because it's x, so that's going to be 0.14. 2 times by 0.14, 2 times 14 is 0.28. Okay, so that will probably be useful for the next part, almost certainly. Now if we read the next part of the question, we are told the spinner is spun 250 times. Work out an estimate for the number of times the spinner will land on blue. Now, the probability that it lands on blue is 0.58. So if we were to spin it 100 times, we would expect 58 of those times to land on blue. And essentially, the way we can work this out is by taking your probability, in this case 0.58, and multiply that by the number of times that you are performing the experiment, which in this case is spinning the spinner. So we're going to multiply that by 250. Now you'll notice that when I scroll down in a second, this is only a 2-mark question, so there is very little to no working out, well, very little working out you would need to do. And really, if you weren't doing this on a paper, you could do this without writing the working out down. It is that simple of a question. So 145 times approximately is what we would expect the number of times the spinner would land on blue from 250 spins. Okay, super. Next question coming up, question 5. Now this looks a little bit interesting. We've got a shape here. composite shape made up of some semicircles. Now, we have got a shaded shape made from 3 identical, so they are exactly the same, semicircles X, Y, and Z. A, B, C, D, E is a straight line. We've got the AC, if I move my head out of the way, AC is the diameter of semicircle X, and B is the centre of semicircle X. BD is the diameter of semicircle Y, and C is the centre of semicircle Y. CE is the diameter of semicircle Z, and D is the centre of semicircle Z. And then, if I scroll down slightly more, we've got the AC is equal to BD, which is equal to CE, which is equal to 20. So we've got the diameter of each of these semicircles is 20. Work out the perimeter of the shaded area. Now, if we know that C to E is the diameter and that is 20, then D to E has to be 10. And similarly, for A to B, that also has to be 10 there. What we then need to do is work out the arc length of the semicircle, the curved part of that semicircle. Now, to get our full circumference, there's 2 formulas you could use. Pi times diameter, most commonly used one, or I say most commonly, it depends what you're doing and what you're given, or 2 pi r, and the reason they are the same is because diameter is 2 lots of your radius. So to get from the top one to the bottom one, you replace the d with 2r, and then with algebra you normally put the number at the front. Okay, so we are given the diameter here is 20, so the circumference of one of these circles is going to be pi times 20, okay, or 20 pi. Now, what we then want to do, because we've got a semicircle, is divide that by 2, okay, so I'm going to do it over to the left hand side. This is going to be 20 pi divided by 2, which is 10 pi. So we've got 10 pi here, we have got 10 pi for this curved part, 10 pi for this curved part. So all in all, that gives us a total of, well, 3 times 10 pi. So 3 times 10 pi, which is 30 pi, plus 2 lots of 10, which gives us an answer of, and this is an exact answer. We will need to, in a second, change this by pressing S to D. If you can hear that, the ice cream van's outside my house. We're going to need to press S to D for this because it says to give our answer correct to the nearest whole number. So we're going to get 30 pi plus 20, which, if I put that into the calculator, will give me an answer of 114 to the nearest whole number. I actually get 114.247, etc. So 114, and we are looking at here centimetres. We are doing perimeter, so it is going to be centimetres, not centimetres squared or cubed or anything like that, because we have worked out a length. Okay, so that question actually wasn't too bad. Just need to take your time with it, not rush it. Make sure you have included everything, because a common misconception with this type of question might be to miss out the 2 tens and not include all of the lengths for your, I was going to say circumference, but it's not circumference, for your perimeter. Okay, moving on then. Now we have got what looks again to be a fairly standard fractions, percentages, sometimes they might include decimals, question. Okay, so Juan wants to buy a ticket to fly from Madrid to Berlin. He finds 2 different types of ticket he can buy in a sale, ticket A and ticket B. Now, ticket A, as you can see, has a 1/6 off the normal price, and ticket B has 20% off the normal price. The sale price of ticket A is €140. Right, so this is actually looking like a reverse fractions, a reverse percentages question. Sale price of ticket A is €140, sale price of ticket B is €136. Work out the difference between the normal price of ticket A and the normal price of ticket B. Now, if we consider A first of all, if there is a 1/6 off of the normal price, that means we have got 5/6 left. So 5/6 of normal price equals, and this is for A, is equal to 140 euros. I'll just put the 140 there for now. Now, we need to work out 6/6. So we need to divide both sides of this, or divide 140 by 5. So we'll get the 1/6, okay, of normal price is going to be 140 divided by 5. Okay, to get from 5/6 to 1/6. 140 divided by 5 is 28. Okay, and then we are, as you probably imagine, times by 6. Okay, so 6/6 of the normal price, or 1 of the normal price, essentially, is 28 times by 6. So 28 times by 6 is 168 euros, and that is for A. So we divided by 5, and then we multiplied by 6. Okay, now you can do a very similar thing with the percentages. So I'll try and fit it in just next to it here so we can see. So we've got B. Now, 20% off the normal price. That means we are left with 100% take away 20% is 80%. Okay, so 80% of normal price is equal to 136 euros. So 136. We are going to, well, there's a few ways we could do this. I'm going to divide by 8 to get 10%. So 10% is equal to, if I divide this by 8, okay, 80 divided by 8 is 10, so you do the same on the other side. What we're essentially doing here is keeping things in proportion. So 136 divided by 8 is 17, okay, and then we want 100%, so we're going to times that by 10, and we are going to get 170 euros. Hopefully you can see that. I'll write it down here, 170 euros. Okay, so for B it's 170 euros, for A it's 168 euros. We need to work out the difference between the normal price. Well, the difference is going to be 2. It's 170 take away 168, which gives us an answer of 2. Okay. Right, now you would want to make sure you put your working out down for that, because there's, well, it's 4 marks, so if we do go wrong, we need to make sure we have got, like I say, the working out down so we can get the marks for that if we make a mistake with the answer. Okay, next question is question 7, and these questions I think are quite nice because what they are trying to test here is that you know or understand a method to find highest common factor, lowest common multiple with products of prime factors. Okay, so here they have got two what are very large numbers but written as products of primes. And for this, the method I use, there's a few methods, but the method I use is a Venn diagram. So we've got A is 5 cubed times 7 cubed times 11 to the power of 6. B is 5 to the power of 6 times 7 squared times 11 to the power of 4. Now we actually only want to work out the highest common factor. The way I'm going to do this, like I say, is with a Venn diagram. I'm going to do that again because that circle was awful. And actually what I can do, which would be a lot better, is actually make some nice circles. So let's do that. There's one. And I will just copy and paste that. Now, because this is working out, I don't actually need to put the rectangle around this Venn diagram like you usually would when you are doing a Venn diagram. Okay, the reason for that is because this is just my working out. It's not for any other reason. It's not for my answer. It's not part of my answer. This isn't my answer. This is just, like I said, working out. So I need to label these then, A and B. So I'm going to call this left circle A. That makes sense. Call this right circle B. Now I then need to work out the highest power of each number that is in both. So if I look at the 5s, so I'll just grab a highlighter here so we can see. If I'm looking at the 5s, 5 cubed, 5 to the power of 6. The highest power in both of those is 5 cubed, okay? So 5 cubed is going to go in the middle. Then if I look at the next one, I've got 7 cubed and 7 squared. Now you might see here what's happening. The highest power that's in both here is 7 squared. Essentially what I'm doing is taking the smallest power of the two, and that is then going in the middle. If I look at the 11s, again we've got a very similar thing here. What colour do I use this time? Let's go with a rose, why not? So you've got 11 to the power of 6 and 11 to the power of 4, and again the highest power that's in both of those is the smallest of the two, which is going to be 11 to the power of 4. Now from there, I don't actually need to fill in the rest of the highest common factor, because the highest common factor is just the middle multiplied together. However, I am going to fill in the rest on this occasion, because if it asked you for the lowest common multiple, you multiply everything in your Venn diagram together. So the rest, well, for A, I've already got the 5 cubed, so that's sorted. I've got 7 squared, and in A I've got 7 cubed, so I need another 7, and then for the 11s, in the middle I've got 11 to the power of 4, I need 11 to the power of 6, so that's going to be 11 squared. Now for the B, I've got 5 cubed, I need 5 to the power of 6, so that's going to be another 5 cubed. I've got the 7 squared, I've got the 11 to the power of 4. Okay, now like I said, for the highest common factor, that is the middle where they cross over, so it's going to be 5 cubed times 7 squared times 11 to the power of 4. That's my answer, because it says in the question, give your answer as a product of powers of its prime factors. So we just give it in the same way that we were given A and B in the question. Okay, moving on then to question 8. We've got to solve the inequality. Now this is the same as if you were solving an equation. I'm going to zoom this in a little bit more so we can see it a bit better. Solve this inequality. Like I say, you solve the same as if you're solving an equation, you just have a different symbol in the middle. So the first thing I'm going to do is cancel out the smallest amount of x's, which is 3x, because I've got x's on both sides here. So to do that, because it's positive 3x, I'm going to subtract 3x from both sides. Okay, now that will give me 8x take away 3x is 5x. Still got the minus 4, and I just copy the symbol. The 3x has been cancelled out with the minus 3x, so I'm left with minus 10 on the right hand side. From there, I need to collect my just number terms together, so my minus 4 and my minus 10. Now I want to get the minus 4 away from my x terms. I've isolated my x terms. Now I've got them all together. I need to get everything else away from them. So I'm going to add 4 to both sides to cancel out the minus 4. That is going to give me 5x is greater than or equal to, now minus 10 add 4 gives us minus 6. Okay. Again, if you're not sure about anything like to do with negatives or anything else numerical, put it in your calculator. Just make sure. You don't want to make any silly mistakes. From there, we are going to divide both sides by 5. Now, you could leave this as a fraction, but because it actually ends up as a nice decimal, I'm going to write the decimal. We are going to end up with, if I write the symbol properly, minus 6 divided by 5 is going to be minus 1.2. So we get as our answer x is greater than or equal to negative 1.2. Okay. Again, like I say, if you're not sure about anything numerical, check it on your calculator. Right, scrolling down, that was only part A. We are now looking at this. I'll have to zoom this out slightly. Maybe a little bit more. We have got basically graphical inequalities. Okay, we've got three straight lines, we've got a shaded area, and we need to work out the equations of the inequalities. So I scroll down slightly, write down the three inequalities that define the region R. So the first thing we need to do here is work out the equations of each of these straight lines, and then we need to work out the inequality to replace the equals with. So the vertical and horizontal lines are pretty straightforward. So this vertical line here, going up from the 7 on the x-axis. Now, because it is going through it's cutting through the x-axis, it's going to be x equals, and because it goes through at 7, it's going to be x is equal to 7. Now, the horizontal line going through the y-axis at 2 here, okay, is going to be, because it's going through the y-axis, it's going to be y equals, and because it cuts through at 2, it's going to be y is equal to 2. Okay, now from there we need to work out the equation of this diagonal line. Now we want to do that by working out the gradient and using the y-intercept. We know the equation of every straight line has the format y equals mx plus c. Okay, I've squashed that in a bit there, but something we should all know. Y equals mx plus c, where m is the gradient, c is the y-intercept. Now, for our line here, our gradient, to a quick and easy way for most lines to work out the gradient, doesn't always work because it depends what your points are and where it goes through. So if it doesn't go through some nice points, as this one does, then you would have to use change in y divided by change in x. But I can see here, if I go right 1 unit, so from 0 to 1, how far, and you always have to go right, how far do I have to go up or down to get back to the line? Okay, so you need to choose a point where the line is on, where your grid lines cross. Now, very easy one for this is 0. But my next nice one is at 1, 1. So going back to what I was saying, if I go right 1 unit, how far up or down do I have to go to get back to the line? Well, I have to go up 1 unit, okay? 1 unit. So that means that my gradient is 1. Now, one way to define your gradient is essentially how many up or down you go for going 1 unit across. So 1 unit to the right, how many units do you go up or down? Okay. Now, like I say, sometimes if your lines don't go through some nice points after 1 unit, or a nice point after 1 unit to the right, it can be difficult to see. If it doesn't go through, you know, like if you're not going 1 up or 2 up or a whole number up or down, you will have to use change in y over change in x and find some nice points where your line goes through where your grid lines cross. Now we've got 1x, it goes through at 0, so we could write plus 0. Now a nicer way to write this is just without the 1 in front of the x. This is a straight line that everybody should know. So y equals x is a standard straight line along with y equals minus x, okay? So that shouldn't be anything too complicated. Now what we have to do from there, I'll zoom it out slightly again, is we have to fill in or replace rather the equals with some inequalities. So the first one here, x is equal to 7, I'm looking at. Now if I look at that line, I want left of that line, okay? So I want all of the values of x that are less than 7. I want 6, I want 5, I want 4, I want 3, etc. I want 2. I don't want less than that, but actually the other inequalities will rule out those other ones anyway. But yeah, so that's what I want. So I need x to be less than 7. Now, is it going to be less than or equal to? Now, The easy way to remember this, for me at least, is if they use more ink drawing their line, i.e. it's not a dashed line, it's a solid line, you use more ink writing your answer, and so you have to put the equals to underneath. Essentially, if it's a solid line, it can be equal to. But the way I remember it, if they use more ink in the diagram, then you use more ink with the symbol, you put the line underneath. Now, the next one is y is equal to 2 we're going to look at. Now, we want the y values that are above 2 because our arrows pointing into our R section are above. So we want y to be greater than or equal to, again, 2. Okay, y is greater than or equal to 2. Now, the last one, the diagonal lines, you need to be careful with. When you have any diagonal line, you need to do your arrows either, well, you need to do them vertically, either straight up or straight down. You cannot do them at angles because then you will start to get yourself confused and make mistakes. So these arrows have to go vertically, up or down. And in this case, we need them to go down. Okay? And so what that means is we need the height to be lower than that line. We need y, which is the height, to be less than. Okay, so we need y to be less than or equal to. And the equation was y equals x, so we need y to be less than or equal to x. And those are our 3 inequalities that define that region. Now, if you want to check that these are right, what you could do is pick a point. So let's go with this point here. 6 and 4. So the x is 6. So if we look at our first inequality, it says x is less than or equal to 7, or 6 is less than or equal to 7, it works. If we look at the next inequality, y is greater than or equal to 2. Well, our y for this point here is 4, and so that is greater than or equal to 2. Now, the final one is y is less than or equal to x. Well, we've got here 4 for the y, 6 for the x, so that is true as well. 4 is less than or equal to 6. So we know that we've done it right. Okay, super. Let's move on to the next question. Okay, next one. Write 5.87 times 10 to the minus 4 as an ordinary number. Now, if it is a negative power, as in this case, it is going to be a smaller number. And what this really means is divide by 10 4 times. So we are going to get 0. We're going to take our decimal place. We're going to move it to the left 4 times. 1, 2, 3, 4. Now, it's a bit hard to see on there because of the words next to 5.87. But if I do it here, 5.87, we're going to divide by 10 4 times. We're going to move the decimal point to the left 4 times. 1, 2, 3, 4. We're going to drop it down here. We've got a 0 out the front, and we fill in each of these gaps with zeros. And so that leaves us with 0.000587. Now, a kind of cheap way with these negative powers with standard form is whatever the number is, in this case 4, that is how many zeros you are going to have at the front of your number. Obviously, 1 will be before your decimal place. Now, the next one is to write a number in standard form. So we've got 84 million in standard form. We need to move our decimal point from here. I'll zoom this in so we can see this a bit better. So our decimal point from here to here, so that we've got a number between 1 and 10. Remember, standard form has to be a number between 1 and 10, less than 10, but could be equal to 1, and you have times 10 and you have a power. So our decimal point is going to move 1, 2, 3, 4, 5, 6, 7 places. It isn't just however many zeros you've got. So it's going to be 8.4 times 10 to the power of 7. 1, 2, 3, 4, 5, 6, 7. And that is our answer. And you should be able to, or you may be able to check some of these on your calculator, depending on how big the standard form numbers are. So sometimes you can do that, sometimes you can't. Sometimes they deliberately make it so that you can't. But just if you can, for this one, I would check it. I wouldn't say particularly that is too big. So if I typed 8.4 times 10 to the power of 7 on my calculator, press equals, it gives me 84 million. So that's a good, easy way to check. Next question is again about standard form. So it's saying the number of neurons in a human brain is 8.5, times 10 to the power of 10. The number of neurons in a monkey brain is 1.47 times 10 to the power of 9. The number of neurons in a human brain is k times the number of neurons in a monkey brain. So we essentially need to work out what you multiply the number of neurons in a monkey brain by to get the number of neurons in a human brain. Work out the value of k. So if we're trying to work out what you would multiply by, then to work out that number, you would divide the two. So, if we make this problem really easy, essentially change these numbers. Let's say this is 8, this is 4. What do you multiply the 4 by to get 8? How could you work that out? Well, what you would do is you would do 8 divided by 4. You would divide your two numbers. So we're going to do that just with standard form. Now, that simplification there is a really good method to help you solve more complicated problems. Reduce the numbers to something which is really simple and think about what you would do, and then apply that process to a more complicated problem like this one. So I'm going to scroll this down so we've got some space to do working out. We're going to do 8.5 times 10 to the power of 10 divided by 1.47 times 10 to the power of 9. Now what we're going to do here is divide our two numbers. So 8.5 divided by 1.47 gives us, we need the answer to one decimal place. This to one decimal place is 5.782, etc. So that gives me 5.8 to one decimal place times 10. Actually, I'm going to have to do a few more decimal places here, and you'll see why in a second. So let me just change that. 5.78. I'll just put ... for now. But that is going to be times 10. And then when you divide your times 10s, you are, because they've both got powers, going to subtract your powers. When you divide, you subtract the powers. So 10 take away 9 is 1. Now, what that means is we need to times this 5.78 ... by 10 once to get the actual value for k. So I'm going to times by 10 on my calculator, and I'm going to get 57.8. Okay, it's 0.82, so it rounds to 0.8 to one decimal place. Okay, and that is our value for k. Super. Now, you probably could have just done that, well, all on your calculator and not even thought about the power of the 10. It would have just probably done it all in one go, or it would have done it all in one go for you. And that's why the question is only 2 marks, because you've got, if I scroll down, 2 marks there. You've got your method, which is one step, and then you've got your answer. Okay. Next question, question 10. We've got this triangle, so we've got an angle of 40 at CAB. We've got a perpendicular height to the base of 8. We've got a base length of 22, and we've got an X at CBA on the right hand side, as you can see there. Now, this automatically already looks to me like a trigonometry Pythagoras based question, because we're working out an angle, at least that's what it looks like, and we've got right angled triangles involved. And all this question says, as you would expect, is to work out the value of x, give your answer correct to one decimal place. So I'm going to zoom this out ever so slightly so we've got a bit more space to write. And I am just going to scroll it up very slightly. There we go. Okay, so what we are going to do is, well, there's a couple of different ways we could do this, but essentially to work out an angle here, we need 2 side lengths. And so I think the easiest thing to do is to work out, let's call this length here D, just for clarity. So I'm going to work out the length A to D. Okay, because if there's a right angle on one side here, there has to be a right angle on the other side. So to work out A to D, I need to use trigonometry. I've got an angle, I've got a side. I am going to start to label the triangle CAD. So 8 is opposite because that is opposite the angle. Opposite the right angle is the hypotenuse, which means that AD is the adjacent. Now, I don't want the hypotenuse and I'm not told what it is, so I'm going to cross that out. And then I've got O and A. Now, that tells me I'm going to use tan. Right, now tan is equal to opposite over adjacent. So tan 40 is equal to 8 over AD. Okay, now I want to work out AD. What I'm going to do is I'm going to times both sides here by AD. So I get AD tan 40 is equal to 8. And then I'm going to divide both sides by tan 40. So I get AD is equal to 8 over tan 40. Now, if you're somebody who uses the trigonometry triangles, you would have done that or got it rearranged automatically from your triangle. Now from there, I'm going to type that into my calculator. So 8 over tan 40 is not going to give me a particularly nice number, so I'm going to have to keep that on my calculator. I can't remove that answer. You could store it if you know how to do that. That is going to give me 9.53. ... I'm going to put. What I'm then going to do is work out the length BD by doing 22, which is the total, minus that 9.53. Okay, I'm going to try and squeeze that in just here. So B to D is equal to 22 minus 9.53 ... I've kept that on my calculator. So BD is equal to 22 minus answer is what I put into the calculator. I get 12.46 ... I want to remember not to round this because then I'll get a rounding error. I'll get my answer slightly wrong and then I'll lose some marks because of that. Now to find the angle from there, I now need to consider, if I scroll up again, the triangle CBD. Okay, so I'm going to label the triangle again. So opposite this angle X is the 8, which is already labelled O, so that's fine. And then the hypotenuse is opposite the right angle, and then the adjacent is the final side. Now again, I don't need the hypotenuse. I'm not trying to find that, and I'm not given it. So what I'm going to do is I'm going to do tan of X. Tan is equal to opposite over adjacent, so 8 over this 12.46 because that is B to D. Okay, so 12.46 ... And so to work out the angle, what we need to do to both sides of that equation is to do tan minus 1. Okay, so if I scroll this down, X is equal to tan to the power of, or inverse tan to the power of minus 1, inverse tan of 8 over 12.46 ... which I'm going to use as my answer button. So that gives me an answer of, so inverse tan, I've got 8 over answer, close the brackets, 32.7 to 1 decimal place, as it says in the question, 32.7. I wrote 37, 32.7. Okay, and that is to 1 decimal place. Okay, super. Right, next question. Okay, so we've got an algebraic fraction here. I'm going to zoom this in a little bit more so we can see it a little bit easier. 3/4 plus 5 minus x over 6x. Now we need both of these denominators to be the same before we can combine these fractions. So I am going to have to times 3/4 top and bottom by x, but I also need the 4 and the 6 to be the same number. So I'm going to multiply, well, what's the lowest common multiple of 4 and 6? I would say that's 12. It is 12. So I'm going to times 3/4 top and bottom by I need it to be an x top and bottom, and I need to multiply also by, what was it? To get to 12, I need 3. So times top and bottom by 3x. Fraction line was awful. So times top and bottom by 3x. I'm going to get 9x on the top over 12x. And then for the second fraction, I've got 5 minus x over 6x times top and bottom here by 2. That gives us 10 minus 2x over 12x. Now we can replace our original fractions in the question with those two and add the numerators. So I get 9 x over 12x plus 10 minus 2x over 12x. Add the numerators. I've got, well, number terms is just going to be 10. I've got 9x minus 2x, which is 7x. And that is over 12x. Okay, now there's no way of simplifying that because there are no numbers that I can divide 10, 7 and 12 by. There's no number apart from one that goes into all three. And so we call those numbers, well, if it was two of them, you call them co-prime. So yeah, co-prime, co-prime, we'll go with that. Okay, so that is our answer. Now, one nice way you could use to check this, if you wanted to check it, is substitute a number for x. Now, obviously that doesn't guarantee it's true for all values of x, but that gives you some more confidence that it's correct. So if I substitute the original question into my calculator, but let's replace x for 3, and then see what we get, and then I substitute my answer in and replace the x with 3. If they're the same answers, then I can be confident that I've done that correctly. So let's try that. I'm going to do 3/4 plus 5 minus 3 over 6 times 3, and that gives me 31 over 36. And if I do the same with the answer, 10 plus 7 times 3 over 12 times 3 is 31 over 36. So, like I say, it doesn't guarantee it for all values of x, but it gives you a bit of confidence that what you've done there is correct. Okay, I'm going to zoom that back out again now. But that was only 3 marks, a relatively straightforward, well, I say only 3 marks, 3 marks for a relatively straightforward question. Okay, the next one is a graph question. It is all about plotting a cubic graph. Now, the first part of this is to complete a table of values. Now, you can use the table function for this on your calculator. Now, I can't really show that on here, or I can try and do it, if you like, with the camera. So, there's my calculator. What you need to do is, I've got an older calculator, so it'll be different on all the different calculators. I'm going to press the menu button. I have got the table function under number 7 on mine, but it will be in different places depending on which calculator you've got. So I press number 7. I then get this, which is asking me, how do I do that? Let me put my hand behind it. Does that work? That's what all the streamers do. It's not working. It's blurring it out. If I put, no, it's basically, it says f of x equals. It says f of x equals, okay? So you will see that. What I might be able to do, actually, is get the, because I had this all set up before, get my camera open for, can I add a camera? Give me one, let's try this. Let's see if I can get this camera working. And then I can show you, hopefully, the calculator. Now I will need to open the camera application. Like a live stream this, apart from it's not, it's just me trying to work out how to show you my calculator. But like I say, everyone's calculators are different, so I could do this and you could have a different calculator and then it doesn't make any difference. But let's try it. Let's try and do it. Okay, so if I add onto this display capture, that's not the one. It might be the one. Probably window capture. Let's try this. Let's call that visualizer. Let's go with that. The name is already in use, is it? Let's go visualizer 1. I don't know what's going on here. Right, select a window to capture. Let's go with camera. That's what we want. Okay, right, so you should be able to see that now, which is good. And I will, basically that's just my camera application, but it allows me to show you, hopefully this, if I turn it the right way around. So you've got, hopefully you can see it there. Say hopefully you can see it, it's gone. F of x equals, okay, so I put in my function. Now, if I turn it that way and just make this a lot bigger, you should be able to see this a lot easier, hopefully. Right, f of x equals, okay? So what we then need to do, if I go back, so if I just hide that, we need to substitute in to that, or type in the equation of the cubic. Okay, so x cubed minus 3x plus 1, okay, is what we need to type in. And I will put the camera up again. So x cubed, so my x on here is in red, so I need to press alpha and then x. I need to press the power button, x cubed, and I believe, and I'll just double check, it's minus 3x plus the 1. So let's do that. So minus 3x, I need to come out of the power, minus 3x plus the 1. Press equals. Now where do I want this to start at? Now if I have a look at the question, it's going from x is minus 2 to x is 2. So I want to start at minus 2 and go up to 2. So start at minus 2, go up to 2, up in steps of 1. So that means it's going to go minus 2, minus 1, 0, 1, 2. And that then gives me all of these values, okay? So coordinates essentially. Minus 2, y value is minus 1. Minus 1, y value is 3. Okay, 0, y value is 1. X is 1, y is minus 1. X is 2, y is 3. Okay, so that's given me all the values there. But if you don't have this on your calculator, everyone should do really, but if you don't, or if you're not sure how to do it, all you do is you substitute your x values into the equation. So we would do 1 cubed minus 3 times 1 plus 1. Now you would want to do the one they filled in to check, excuse me, that you're doing this correctly. Right, now let's copy them from my calculator. So minus 2 for x is minus 1 on the y. Then we've got 3. Then we've got 1. Then we've got minus 1. That's the same on my calculator. Then we've got 3. Okay. Now from there, that's the first bit done. Got 2 marks. Easy. Next part is to put that onto the graph. So we need to plot all of our points. I would do these with crosses so that when you draw your smooth curve for the cubic, the examiner, the person marking this, can see where your points are. And there are marks if you lose, well, there are marks basically for getting your points correct. You know, majority of them correct. You might get one wrong and that means you lose some marks, but if they can see the rest of them and you've done them correctly, you will guarantee yourself some marks. So we need to do minus 2 and minus 1. Now x is along the corridor, so minus 2 down to minus 1, across there. Then we've got minus 1 and 3, so that is up here. 0 and 1, which is here. And then we've got 1 and minus 1, which is here. And then we've got 2 and 3, which is up here. Now for a cubic or a quadratic, you need to do a smooth freehand curve, and we only need to draw it from minus 2 to 2. So we don't need to go, we don't need to extrapolate this, we don't need to go further than the points that we've got. Now I will do this the best I can using the software I've got and basically the way I'm doing it. I'm using a drawing tablet if anybody's interested, so something like this. So I'll do the best I can. Obviously if I was doing this on paper, you use a pencil so you can rub it out. I can rub this out, but yeah, so it's a bit difficult on this drawing tablet, so let's give it a go. Okay, so we go up. Right, I'm going to try that again. See, it went wrong. I didn't like the fact that I had that kind of wiggle in the curve. It needs to be a smooth curve, so we're going to try that again. Okay, so I got to that point. Going up here, I'm going to do a smooth curve. I'm going to go down through there. I'm going to carry that on. We go down here. I'm going to turn there and I'm going to go back up. And you want to keep this as best you can being a smooth curve. I didn't like the end of it there, so I'm going to redo that bit. So smooth curve is what I want. Okay, that's pretty good. Okay, it's not my best attempt because, like I said, I'm not doing this on paper. It's a lot easier on the paper because you can turn the paper and you can basically use your wrist to do the curve. Makes it a bit easier. But yeah, that's what you need to do, and you don't need to go beyond x is minus 2 and x is 2. Okay, next part of the question, we have got, and I have to zoom this out so we can see them all, we've got 4 graphs here. Write down the letter of the graph that could have the equation y is equal to minus 1 over x squared. Now, all of these are some variation of reciprocal graphs because of the curve shape. Okay, it's this shape here where it's going down and it's getting closer and closer and closer to the x-axis, and if you go up, getting closer and closer to the y-axis but never touching it, are reciprocal curves, 1 over. Now, what you may want to think about with these is transformations of graphs. Now, the 1 over x squared, so if we had y equals 1 over x squared, that would make everything positive, okay? So we would end up with b, that would be b. But we haven't got that. We have got y equals minus 1 over x squared, okay? So what we'd want to do is to think about, actually, our transformations. If we had minus f of x, y is equal to minus f of x, what does that do? And what it does is it flips, it basically makes all the y values negative. So it's going to flip it over the x-axis. Okay, so what we would end up with is flipping b over the x-axis, we would end up with d. Now, one nice way to think about this is just to try some values for x. So on my calculator, if I type in minus 1 over, let's go with 3 squared, I get minus a ninth. If I do a smaller number, so get closer to the y-axis, so if I do minus 1 over 0.1 squared, I get minus 100. But you can see it's always going to be negative, our answer. Our y is always going to be negative. And so that makes sense with what we've got. And I could try a negative value, but be careful on your calculator because when you have a power of any negative, you have to put the number, the negative number, so the base, the big number, in brackets. Okay, and then that will still give you a negative answer because you are squaring a negative, which makes it positive, and then you have the minus outside the fraction, which makes it negative again. Okay, lots of negatives talked about there. Next question, question 13. So here we've got a cumulative frequency graph. Okay, I'm going to zoom this in a little bit so we can see it a bit easier. We've got a cumulative frequency graph, and it gives information about the times and seconds that 80 adults took to log into an online bank. We don't have to draw the cumulative frequency graph for this question, so we don't have to worry about that. We just have to find an estimate for part A, wrong way, for part A, of the median time. Now, we can see on the graph, the highest point that our graph goes up to here is a height of 80. You need to check that because sometimes the axes, the y-axis goes higher than the graph actually goes, so just be careful. We are going to half the total height the cumulative frequency graph goes up to. So half of 80 becomes 40. So we are going to draw a line across from 40 to my cumulative frequency line. I am then going to draw a line straight down, and where I touch the x-axis would be my answer. So that touches the x-axis there at 25. So that is the estimate for the median time, 25. Now, the next part of the question says, work out the percentage of these adults that took longer than 50 seconds to log in. Now, longer than 50 seconds. So what we need to do here, again, is we need to draw a line up from 50 seconds and a cross. So I am going to get to the line here, and then I'm going to go across from where it touches that line. That isn't where it should be, but I'm going to move it in a second again. But a slight limitation of the software, let's say. So I'm going to put that there, extend it over, and what I've got is 75. Now, that 75, that means there's 75 people that took less than 50 seconds, okay? 75 people took less than 50 seconds. Because cumulative frequency graphs, if you use them in this way, they are always talking about that number or less, okay? 75 people took 50 seconds or less. We need to work out the number of people that took longer than 50 seconds. Well, it goes up to 80. So we are going to do 80. Subtract 75 is 5 people took longer than 50 seconds. We need to now make that into a percentage. So we need 5 as a percentage of 80. So the way to do that is to write it as a fraction. First of all, 5 out of 80. And then we need to change that into a decimal, which our calculator can do by pressing S to D. From a decimal to a percentage, you are going to times by 100. So we are just going to put that into our calculator. 5 divided by 80 times by 100 is 6.25%. And we shouldn't have to round that because it doesn't say in the question to round to 1 decimal place or anything else. So the fact I've got a whole number gives me confidence that that's correct. Okay, moving on then to the next question, question 14. This is about the point in the paper that the questions start to get more difficult or perhaps more interesting, if you think about them like that. I'm just going to zoom this out ever so slightly, and then I can slide it across so we can see the question a bit better. Okay, so this is question 14, and we are told that A, B, and C are points on a circle centre O. Angle OAC is 52 degrees. Find the size of angle ABC. So we need to work out this angle up here. Give reasons for your working. Now, the way to do this is, well, I'll show you. Obviously, I'll show you. That's the whole point of the video. This angle here, OCA, has to be 52 degrees also. And the reason that is because OAC is an isosceles triangle. So, and again, the reason that's an isosceles triangle is because O to A is a radius of the circle and O to C is a radius of the circle. So those two lengths must be equal. So what I'm going to write is OA is equal to OC as they are radii. And then I'm going to write OAC, so angle OAC is equal to 52 degrees as base angles of an isosceles triangle are equal. Now, you may be worrying, or may have worried, or may worry about spelling isosceles correctly. They won't. An examiner won't worry about that. You know, if they can clearly see you meant to write the word isosceles, it doesn't matter if you've put the C in the wrong place. I've done it plenty of times. I may have done it there. It doesn't matter, okay? As long as it's clear what you're saying and what you mean. Okay, so 52 degrees as base angles of an isosceles triangle are equal. We can then work out this angle here, and that is going to be 180. So I'll just do my working out up here. Actually, no, I'll do it in my explanation. That's probably a good place to put it. So, angle AOC is equal to 180 minus 52 minus 52, which is equal to, well, that's 104, so it's going to be 76 if I've got my maths correct. 76 degrees as angles in a triangle sum or add to 180 degrees. Now we're nearly there. The last thing we need to do, and I'm going to zoom it in on the circle for this bit so we can see it. So this circle here, we know this is 76. The last part is something which is a little bit sneaky because they have deliberately crossed BC over this smaller triangle AOC. Now if it wasn't where it is, if it was over here, then I think most people would know what the angle was. And actually it doesn't matter that B is where it is. It could be any point on the circumference of that circle. But you probably know that the angle at an arrowhead, or the angle on the circumference, is half the angle at the centre, or the angle at the centre is double the angle at the circumference, etc, etc. And if you forget which way round it is, sometimes I do, you can normally tell from the diagram which one's smaller and which one's bigger. Okay? So it's going to be half of 76, essentially. So if I scroll down, I am going to just put that into my explanation now. So I've got the angle ABC. Angle ABC is equal to 76 divided by 2, which is equal to half of 70 is 35, half of 6 is 3, 38 degrees, as the angle on the circumference is half the angle at the centre. Okay, so our answer is 38 degrees, but as it says, we need to give reasons for our working. So we need to explain every single little thing that we do. We don't want to forget anything, we don't want to miss anything out, because to get full marks you need to have everything written down and explained. Okay, moving on then to question 15. Quite a nice question, I think. Again, I'm going to zoom this one in because it's just easier to see. So we've got this, x is equal to 3p plus n over 3n minus 4, and we need to make n the subject, which means we need to have n equals at the end. So first thing I'm going to do is I'm going to write the question out. X is equal to 3p plus n over 3n minus 4. I'm going to do the fraction line again because, again, not great fraction line. That's better. I'm going to multiply both sides of the equation here by 3n minus 4. So I'm going to times both sides by 3n minus 4. That will cancel out the denominator on the right-hand side. So that will give me x brackets 3n minus 4 is equal to 3p plus n. We then need to expand the brackets. So we are going to get 3nx minus 4x is equal to 3p plus n. From there, we need to make n the subject. We need to get everything with n in it, every term with n in on one side, everything else on the other side. So I'm then going to add 4x to both sides. And I'm going to get 3nx is equal to 3p plus the n plus 4x. From there, I want to collect the n term, so I'm going to minus the n from both sides, and you could have done that before. Now, we can't take away n from 3nx because it's got a different combination of letters. Okay, 3nx we have to write as just 3nx minus n equals 3p, that n disappears, plus the 4x. And then what we are going to do is we're going to factorise the n out on the left-hand side. So we're going to get n brackets 3x minus 1 is equal to 3p plus 4x. And then I'm going to divide both sides by the bracket 3x minus 1. So divide by 3x minus 1. That gives me n is equal to 3p plus 4x divided by 3x minus 1, which is the answer. I'll scroll down. Sorry, there you go. Okay, so now what I'm going to do, I'm just going to write that on the answer line. That's my answer. So we've got, here we go, n is equal to 3p plus 4x all divided by 3x minus 1. I need to make sure there's no n's left on the other side of the equals. It needs to be n equals and no other n's. And also you need to be careful with your algebraic working out. But with something complicated like this, where we've got n's on the top and the bottom of a fraction, you need to multiply by your denominator, expand the brackets, collect the n's on one side, factorise and divide. Okay, next question is this one. And this is a differentiation question. I know that because it's talking about gradient, and I've got a cubic, or a more complicated quadratic, cubic, polynomial, more complicated polynomial. Now, to find the gradient function, we differentiate. So to differentiate this, I write dy over dx equals. Now, to differentiate, you bring your power down the front, and if there's a number in front, such as 4 here, we're going to multiply that. So I'm going to do 3 times 4 is 12x, and then I am going to take 1 away from the power, so 12x squared. Minus 8x, the power of that x is 1, so I bring the power down the front. Minus 8 times 1 is minus 8. We get x to the power of 0, which becomes 1. So that x is just going to disappear in that case. And the constant term 5 is just going to disappear. And if you want to know a reason for that, well, that's x to the power of 0. 0 comes down the front. 0 times 5 is 0. X to the minus 1. 0 times anything is 0, so it's gone. So this is our gradient function. This is our function to work out the gradient at any x value on the curve. So we need to work out the x coordinates. So we're going to do 12x squared minus 8. We're going to set that equal to 1/3. And then we're going to solve it. And so to solve that, we need to add 8 to both sides. I'm going to do this all on the calculator. I'm not going to worry about keeping it as a nice fraction or anything like that. So I'm going to 8 add 1/3, which gives me 25 over 3. I'm then going to divide both sides by 12. And then I'm going to square root. So I've got x squared is equal to 25 over 3 divided by 12 is 25 over 36, which is a nice number because I can square root both of those. So I'm going to square root top and bottom. It's not top and bottom. Well, yeah, top and bottom of the fraction, but left and right is what I meant of the equation. So square root both sides. We are going to get x is equal to square root 25 is 5, square root 36 is 6. So we get 5 over 6 as the answer. However, we need to be careful here because when you square root, you get two answers. You get a plus or positive, and you get a negative. Okay? So you get a positive and you get a negative. And it does say in the question, it gives this away. It says find the x coordinates of the 2 points on the curve. So the x coordinates are minus 5 over 6. Okay, so x is equal to minus 5, 6, or x is equal to plus 5, 6. They are our 2 points, or 2 x coordinates, which is all we need. Just check with these questions as well. It doesn't ask for the y coordinate. No, it just wants the x coordinate. It doesn't want a pair of coordinates. So that's our answer. X is minus 5, 6, or x equals 5, 6. Okay, so moving on to question 17. Question 17 is given us a histogram, and it's got information about weights in grams of some oranges in a box. it says that 24 of these oranges weigh less than 20 grams. So less than 20 grams is that box from 0 to 20 along our x-axis. Now we know with a histogram that the frequency represents the area of each box or bar. So this has an area of 24. Now that will allow me to work out my frequency density or my scale for my y-axis, because I know that 20 times by something is 24. Okay, so if I do 24 divided by 20, that will give us what the height of that rectangle has to be, which is 1.2. And that is the frequency density for that bar. So this is 1.2, which means, therefore, that we've got 12 little squares that make 1.2. So 10 squares, which is a nice scale, is 1. So this would be 2, 3, etc. 4, and we don't need to go up to 5 because none of the bars go up to 5. Now, what I want to do from there straight away is to start working out the frequencies for each of the intervals. So we've done 0 to 20, we know that's 24, but then doing 20 to 30, 30 to 50, 50 to 65, and 65 to 75. And we could now do that with our scale. Sorry, if you couldn't see the 24 divided by 20, there it is. Now, looking at our question, it says medium oranges weigh between 35 grams, so that would be from here to 55 grams. Okay, so we are going to need to work out the frequencies for at least 30 to 50 and 50 to 65. We don't actually need the other two bars, the frequencies for those two, but it makes sense to work them out at the same time. So let's work out the frequencies for all of these bars. So I've got from, well, a width of 10 for this next bar, 20 to 30. 10 times by 3.1234 is 34. The next one has a width of 20 and goes up to a height of 2.2. Now 2.2 times by 10 is 22. Times that by 2 is 44. And the next one goes from 50 to 65, which is a width of 15 and goes up to a height of 1.8. So we need to do for this bar 1.8 times by 15, and that will give us 27. And then for this last one, we're going from 65 to 75, so that is a width of 10. So we're going to do 10 times by, the height is 0.6. Okay, so that gives us an answer of 6. Okay, now to do the next bit, we are going from 35. So we need the number between 35 and 55. Now, one way to do this is to just split it up into the number of medium-sized boxes, but you can see that's going to be a problem because for 30 to 50 I don't have an exact number of medium-sized boxes, actually, nor do I for 50 to 65. However, what I can do is split it up like this into kind of vertical strips, essentially. So I've got 4 equal vertical strips for the 44, and actually I need this one, this one, this one. So I need 3/4 of the 44. Now for the 27, if I do the same thing, so my vertical strips here, I need 1 of those. So I need 1/3 of 27 and I need 3/4 of 44 and add them together. Now another way of doing this is working out the unsimplified fractions, essentially. And this is a method which will be easier if they're not nice fractions like we've got here, like 3/4 and 1/3. So in this case, I go from 35 to 50. So that is 15. Scroll down. So that's a difference from 35 to 50 of 15 out of a total width of 20. So that gives me my 3/4. Yeah, from 30 to 50 is a total width of 20, but from 35 to 50 is 15. So we want 15 out of 20 times by the 44. And then we want, for this 27, we want to go from 50 to 55. So that is a width of 5 out of a total width of 15. There's our third, times by the 27. That will give us an answer of, well, 3/4 of 44 is 33, and 1/3 of 27 is 9. Add those two together, we are going to get an answer of 42. There you go. So that is our answer there, 42. Okay, moving on then to question 18. And I might need to move out of the way for this so we can see all the writing. I might zoom it out very slightly. There we go. So the diagram shows the positions of 3 villages, A, B, and C. Now, clearly, they've joined all the points up for us already, but quite often with bearings, you've got parallel lines, angles and parallel lines involved. You might have a triangle like we've got here. The bearing of B from A, so the bearing of B from A, 0, 5, 4. The bearing of C from B is 132, like we've got on the diagram. Meller? I'm not sure if I'm saying that right. If there is anybody with that name, maybe you could explain how your name at least is said in the comments down below. But yeah, we'll go with that. Meller walks from A to B. She then walks from B to C and from C to A. So she walks from A to B, then from B to C, then from C to A. Right, I'm just getting my head around that. Meller walks at an average speed of 6 kilometers per hour. Work out the total time Meller takes. Now, in order to work out the total time, we've got the speed, we need the total distance. Okay, so we need to work that out. Now, I said before we even started reading this question, I think anyway, that parallel lines are quite common with bearings, and that's because you've got your north lines which will always be parallel. Now if this bearing at A is 54 degrees, then I know that this angle here is a co-interior angle to that 54, and so has to add up to 180. So if we do 180, subtract the 54, we are going to get 126. So this is 126. We can then work out this angle inside the triangle, so angle ABC, by doing 360, take away 132, take away 126, and that will give us an answer of 102 degrees. So that's 102. And we've now got a triangle with 2 sides and an angle in between those 2 sides. What we can then do is use the cosine rule, because we, including the answer, are going to have 3 sides and an angle. So that tells me that it's cosine. Right, so the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a, where capital A is opposite lowercase a. Now, that should be, and I can scroll very quickly back up, I believe that is on the formula sheet. So let's scroll all the way back up and just make sure. There you go, you've got your cosine rule right here. So if you don't need to remember that, sometimes it might be helpful if you do, but you would want to check it. Just like with the calculator, where, you know, if you're not sure about anything, make sure to check. Same thing in this scenario. If you're not sure, make sure to check. Right, now B and C don't matter, so that could 3.6 could be B, 8.4 could be C. Doesn't matter if it's the other way around. The only one that is important is the A, that has to be opposite your angle. Okay, so I'm going to say AC is the side I'm working out squared is equal to B squared, which is 3.6 squared, plus C squared, which is 8.4 squared minus 2 times by B, which is 3.6, times by C, which is 8.4, times by cos of 102. Okay, from there, we are just going to tidy all of that up, get an answer for that. It's going to be a decimal, and then we are going to square root it. Okay. Oh, just bear with me 1 second. The technology has decided it's going to have a break. AC squared is equal to, and I'll grab my calculator, put all of this in, all in one go. 8.4 squared minus 2 times 3.6 times 8.4 times by cos of 102, and that gives me 96.094 dot dot dot. So we then want to square root that, and I put dot 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 because I want to keep that answer on my calculator. Okay, now if we square root that on the calculator, we get, using the answer button, we get 9.8, again 027. Now we want to keep that on the calculator because that has got more decimal places, and that is just the total length of A to C. We then need to answer the question by getting, doing speed, distance, time with the speed and with our total distance. Now, bear with me 1 second because for some reason my tablet has run out of charge. So let me just quickly find the charger, the lead for that. I've got it here somewhere. Right, where's it gone? It should work. Let's see, let's see. This is definitely a different charger. It's not for this thing, but it may just work. Let's have a go. Right, we may be back on. We are back in business, people. Look at that. Okay, so like I was saying, AC. Oh, say back in business. Technology, hey, never rely on it. Especially not ChatGPT. Always gets things wrong. So AC is equal to 9.80 dot dot dot. So I've got that still on my calculator. There. You can't see it. We had this issue earlier. But that is AC, so I now need to add all of those lengths up. So I'm going to do 3.6, add 8.4, add 9.80 dot dot dot. 3.6, add 8.4, add 9.80 dot dot dot. So I'm going to get 3.6, add 8.4 equals 21.8 dot dot dot. Okay, 80 dot dot dot. From there, speed equals distance over time. Okay, so speed equals distance over time. I am given the speed, I've got the distance, so I am going to do distance divided by speed will give me the time. If I times by time divide by speed, I get time is equal to distance divided by speed. Okay, if I'm doing, this speed 6 kilometers per hour, if I want to walk 60 kilometers divided by 6 gives me 10 hours. That's how long it would take me. So let's do that with our numbers. I'm running out of space here, as you can see, but our distance is 21.80 dot 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 divided by, 6. So 21.80, our answer, rather, keep that on your calculator, divided by 6 gives 3.633. Now, I need to change that into hours and minutes. So 3.633 dot dot dot. Now, I'm going to show you one nice thing you can do on your calculator to change this from a decimal in hours to hours and minutes. So let's try and do this with the camera again like we did last time. Right, so camera is some way off for some reason. Let me just sort that out. Okay, so we've got this. There's my number. What I want to do is I want to press, and I'm really close to the microphone now, so I apologise if it's too loud. There's this button here that you can see. All right, move it into focus a bit more. If I press that button, that will change it into hours, minutes, and then we've got seconds. Okay, so 3 hours, 38 minutes, and 1.67 seconds. So 3 hours, 38 minutes. Now that is not the nicest number because I've not got a whole number of minutes, so I feel like I want to check that. Now, if you're not sure about this, let me just press S to D, change it back. No, it's not working. Let me do it that way. There we go. Right. If you don't have that button on your calculator or you're not sure where it is, what you can do is take away your number of hours, so take away 3, and then times that by 60, okay, to get it into minutes. And there we go. Right, so 3 hours, 38 minutes. I'm just going to double check my working out. So I'm going to now get rid of that camera. So having a quick look again, I have done 180, take away the 54 to get the 126. So I'm just rerunning through this on my calculator just to make doubly sure. And if you're in an exam and you get something like this and you're not sure, this is the procedure I would go through. Just reread what you've done, make sure it makes sense, make sure you check on your calculator, your calculations, and they will give you the correct answers, the answers you'd expect, because you'd be surprised how many times people type things into their calculators, myself included, and it gives you completely a different answer to what you've written down. So, you know, it happens. 102, that's right. And then we've typed all of that into the calculator. Let me check the cosine rule part that I typed in. 3.6 squared plus 8.4 squared minus 2 times 3.6 times 8.4 times by cos. And check that your calculator, when you are, and this is one thing I just checked, when you are doing any trig function, sine, cos or tan, has a D at the top. I'll show you of the calculator. The reason that is, if you don't, your calculator, so here, that D there, if that is not a D, if that is an R or even a G, then that means that you are using a different angle unit, and therefore it won't give you the correct answer for cos 102. So yeah, just double check that. Yeah, I got 96.094, which is what I got before. Square root the answer. Yeah. Okay, so 3 hours, 38 minutes. I've gone through it all. Seems like it's correct. Okay, even though it feels like it probably isn't because we've got an awkward number. But yeah, there we go. Okay, moving on then to the next question, and that is question 19. Sequences question. These are fairly common towards the end of a paper, an IGCSE paper that is. So first 4 terms of an arithmetic sequence are this. So this is going up by 4 each time. Zoom this in a little bit more. There we go. It's going up by 4 each time. The last term of the sequence is x, okay? So dot, 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 x. We don't know how many terms are in there, but it says the sum of the terms of the sequence is 7,260. Find the value of x. Now, there are a couple of formulas for the sum of a series, or one formula for sum of a series, but another one for nth term, which you probably will not be used to. So it's a plus n minus 1d. Okay, that is the formula for nth term. You can also rewrite it in the other way, but this is easier in some instances. Now, there is a formula, like I say, for the sum of a series, and that is on the formula sheet. So I'm going to very quickly scroll back up to the top, find that formula, just double check it, because I think I can remember it, but I'm not 100%, so I want to double check it before I write it down. So let's do that. Scrolling all the way back to the top. Nearly there. There we go. Right. So on the formula sheet, it is right here. Sum to n terms is n over 2, square brackets, doesn't have to be though, but it just separates out from these curly brackets. N over 2 brackets 2a plus in brackets n minus 1d. Okay, so let's write that down, all the way back down. Nearly there. Okay, here we go. So, sum is n over 2, 2a plus n minus 1d. Okay? Right. So we are going to use that and substitute the values in. I'm just going to quickly double check one more time. N over 2 brackets 2a plus n minus 1d. Got it. It's worth double checking because, again, surprised how many times people get stuff like that wrong. Although it probably gave you a headache, and I apologise for that, scrolling up that quickly and back down that quickly. So, sorry. We don't know what n is, and n is what we're trying to work out, but we can substitute into this. 7 to 60 is the sum of those terms. N over 2, square brackets, 2 times a. A is your first term, okay? So 2 times 3 plus n minus 1. Now, d is your common difference, which is 4. Okay, it was going up by 4 each time. So we've got this equation here. Now we need to simplify this as much as we can and solve it. So first thing I'm going to do is just simplify things inside this bracket. So n over 2, and then 2 times 3 is 6, plus 4 times n is 4n, minus 1 times 4 is minus 4, square bracket. 7 to 60 is equal to n over 2. And then we've got 4n, and 6 minus 4 is plus 2. And then what I want to do from here, the next line is times both sides of the equation by 2. Okay, so 7 to 60 times by 2 is 14,520. And that is equal to n times by 4n plus 2. So I'm going to expand the bracket now on the right hand side. I'm going to get 14,520 is equal to 4n squared plus 2n. You can see now we've got a quadratic. I'm going to divide everything here by 2 because everything is even, so that's going to make things maybe slightly easier. So I get 2n squared plus n is equal to 7,260 again. Get everything onto one side, so I'm going to take away from both sides here 7,260. Okay, now from there I could explode the middle. The better way, I think, to approach this, because of the, how big c is, minus 7,260, would be to use the quadratic formula. And the quadratic formula is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I've used that so many times I can remember it off the top of my head. Now a is going to be, I'll use green to show you this, a is going to be the 2, b is actually going to be 1, and c is that minus 7,260. So let's use the quadratic formula. I'm going to write down what I'm going to put into my calculator. So I'm going to put in minus, not b, started off wrong already, minus 1 plus, now you can't put plus and minus into your calculator in one go, so we're going to start off with plus and then change that to a minus afterwards. So square root of 1 squared minus 4 times by 2 times by negative 7,260. Now when you put any negatives in, just put them in brackets. That will ensure that you never go wrong with the quadratic formula. Always put any negative numbers in brackets. Okay, obviously this one at the start isn't a negative number, it's come from the minus in front of the b. Okay, so line underneath that, fraction line, and then we've got 2 times a, which is 2. And so we're going to put that in our calculator with the plus, and then once you've done the plus, you're going to change that plus to a minus, which is where the plus and the minus comes from. That's what that means. Do one with a plus, do one with a minus. That gives us, I put x here, really, I should have put n, but it doesn't matter. because what I'm working out in this case isn't x like it normally would be, it's n. So our values for n are, give me 1 second, put this into the calculator, 1 squared minus 4 times 2 times minus 7,260 divided by 2 times 2. We get n is 60, or n is equal to minus 60.5, which doesn't make sense for a couple of reasons. N is our term number, and our term number can't be negative, nor can it have a decimal place in it. Okay, it's got to be an exact positive number. Okay, a whole positive number. So n is 60 is the number of terms. Okay, n can't be negative. Scroll that down so you can see it. N can't be negative. And if I scroll back up to see the question asks, find the value of x, and x is the last term. So if we use this here for our nth term, okay, we know the a, we know d, we know n. We're going to substitute those values in, and we are going to get the answer. So a is 3, d is 4, and n is 60. So we've got 3 plus n, which is 60, minus 1 times by 4. That will give us our last term, our value for x. So 3 plus 60 minus 1 times by 4 is 239. There we go. Okay. Now there's no real or easy way immediately that I can think of to check that, other than potentially going back to here and substituting the value for n into it, and doing it that way and checking that way. But I'm fairly confident because n is the nice whole number 60. I'm very confident, to be honest. Right, next question, 20. This is quite a nice probability question. So a bag contains only 10-cent coins and 20-cent coins. Josip takes at random a coin from the bag, records its value and replaces it in the bag. He then takes at random a second coin from the bag, records its value and replaces it in the bag. Josip finds the mean value of the two coins. The probability that the two coins have a mean value of 10 cents is 49 over 121. Work out the probability that the two coins have a mean value of 15 cents. Now, the bag has only got 10-cent coins and 20-cent coins in, and we don't know how many of each are in there. But we know that there is replacement, which is important because that means the probabilities each time are not going to change. They're going to be fixed. They're going to be the same. Now, with this kind of scenario, taking things out of a bag, I would be inclined to use a tree diagram. Okay. So we've got, here we go, we've got draw 1. Actually, do you know what? I'll put first and second. That'll be better. So first draw, second draw, and then we've got 10 cents and we've got 20 cents. Now, the only way of taking two coins out and then them having a mean value here of 10 is for both coins to have a value of 10. 10 add 10 divided by 2 is 10. If you had 10 and 20 and did the mean of them, 10 add 20 is 30, half of that's 15. 20 and 20, add together half it, will give you a mean of 20. So that means this value here, let's call it x for now, times by x, would give us, so x squared, you times when you go along your branches, remember, equals 49 over 121. So if we square root both sides of that, we're going to get that x is 7 over 11. Now I can then replace, or right next to it, should I say, that the probability of getting a 10-cent coin is 7 over 11, which then means that the probability of getting a 20-cent coin, because you've either got a 10-cent coin or a 20-cent coin, would have to be 4 over 11. And because we're replacing, that is going to be the same, or those probabilities are going to be the same on all of the corresponding branches. So for the 20 up here, it's 4 over 11. For the 10 here is 7 over 11. 20 here is 4 over 11. Now, the last line of the question tells us to work out the probability the two coins have a mean value of 15 cents. Now, to get a mean value of 15, we would have to have one coin with a value of 10 cents and one coin with a value of 20. Now, there are two ways we can do that. Okay, we can go up this way and down, so a 10 and a 20, 10 first, 20 afterwards, or we could have a 20 first and a 10 second. So, working out the probabilities of those two branches, we've got 7 over 11 times by 4 over 11, which will give us 28 over 121, and it would be the same, but the numerators would be the opposite way around for the bottom option. 4 over 11 times by 7 over 11 gives you again 28 times 121. Just remember, when you go along your branches, you need to multiply to get your probabilities. Now, because we could have either of those options, we are going to add the two answers together. So we're going to have 28 over 121, add 28 over 121 equals 56 over 121, which I don't believe we can simplify, but let's just double check on the calculator. No, we can't. So that is our answer, 56 over 121. Super. Next question, question 21. Now we've got this shape here. I'm going to have to zoom this out very slightly. Here is a triangular prism, A, B, C, D, E, F. Now this immediately looks to me like 3D trig, 3D Pythagoras. We've got the AD is 53 centimeters. We've got that DF is 28 centimeters. We've got that angle FDE is 30 degrees. Work out the volume of the triangular prism. Okay. Now we've got a couple of right angled triangles here to notice. Now, to work out the volume of this triangular prism, I need to work out the area of this cross section at the end, and I also need to work out the length or depth, if you like, of the prism. So, first thing I want to do is try and work out this end triangle. Now I've got 28 as one of the lengths and I've got 30 degrees. So what I can do there is use trigonometry, and it's just about there which side I want to work out. And it doesn't really matter, because you could do this in a couple of ways. You could do this with Pythagoras, so you could, well, trigonometry first, then Pythagoras. So I could work out the side opposite the 30 degrees, so this side, and then once I've got this side and the hypotenuse, I could work out DE. Then I've got base times perpendicular height and half it to get the area of that triangle. The other way I'm thinking of doing this is to use trigonometry to immediately work out DE, right angle trigonometry, and then I can use a half AB sine C with DF, DE and the 30 degrees to get me the area of the triangle. So there's a couple of ways. Probably the second option there is quicker, but it's using maths which may be unfamiliar or more unfamiliar to some people. So what I will do is I am going to do the first way, although it may not be the quickest, but just to, yeah, people may be more familiar with that. So let's go with that way. Now, the first thing I'm going to do is draw a sketch. Okay, so this is my sketch. It's not for part of my answer. It doesn't have to be accurate. Just a very quick sketch. So I've got D, F, and E. I've got my right angle here. I've got my 30 degrees. I've got my 28. So we'll change that O so it doesn't look like a 6. Okay, now I am going to work out this side by doing 30 degrees. That is my opposite. This is my hypotenuse. This is my adjacent. I don't need that, nor am I given it. So I'm going to ignore that. So it's O and H. So sine 30 is equal to opposite divided by hypotenuse, which is 28. So to work out the opposite side, F to E, okay, I am going to times both sides by 28. I'm going to do 28 times by sine 30. That will give me an answer of, hopefully something very nice. 28 times by sine 30 is 14. Okay, so we've got a height here of 14. I can put it on my diagram. Then I do need to work out my adjacent. Now, I could use trigonometry here again, or I could use Pythagoras. Either way will work. What I'm going to do, just because I've already used it, is use trigonometry again. And I could use either O or H here. So any trig function for this next bit will work as long as you do it correctly. So let's go with, because we just worked out the opposite, let's go with that one. So we're going to go with opposite and adjacent. I'm going to ignore the H. So opposite and adjacent is tan. So tan 30 is equal to opposite over adjacent. So 14 over the adjacent. Now what I'm going to do here is I'm going to times both sides by the adjacent, divide both sides by tan 30. And it's going to look like the adjacent and tan 30 swap places. And in reality they do, but it's because of those things I've just said. Times both sides by the adjacent, so the adjacent comes up here. Divide both sides by tan 30, so that would come down there. So we get the adjacent is equal to 14 over tan 30, which gives us an answer of 14 root 3. Not the nicest number in the world, but that's okay. Right, from there, we've got the base, we've got the perpendicular height, so we can work out the area of this triangle quite easily, really. So I'm going to draw my triangle again. I've got 14 root 3. I've got a height of 14, so I'm going to do half the base times by, scroll it down so you can see it, there we go, half the base times by the perpendicular height, which is 14. That gives me an answer of 98 root 3. Now I'm going to go back up to my diagram now and just put that on. So I've got this area is 98 root 3. I need to work out this length here, A to F. Okay, now I've got this right angle in this corner, which is really going to help me here, because all I need to do to get this side is do Pythagoras, because I've got the hypotenuse being 53. So I'm going to do 53 squared minus 28 squared, and I'm going to square root it. Now, because I'm working out a shorter side in that triangle, i.e. not the hypotenuse, I am going to subtract. If I was working out the hypotenuse, I would add those numbers together. But obviously I'm not, because 53 is the hypotenuse. So, square root of 53 squared minus 28 squared gives 45. Again, a nice number, which gives me confidence that I've done that right. So I'm now going to do 45 times by 98 root 3, the area of the triangle times by that length. So scroll down, 98 root 3 times by 45. That was correct. I'm not making that up. That is correct. Times by 45 gives us an answer of, and does it say to round it? Correct to the nearest whole number, it does. So 7638 centimeters cubed to the nearest whole number. Okay, that carries on to being 7638.34061. Okay, super. Nearly there. Next question. This is a nice question, this one. We've got to draw a diagram for this, that's for sure. So I am going to make, hopefully, should be, anyway, a nice diagram for this. Let's do a set of axes. So there we go, that'll do. And then I am going to zoom it out very slightly as well, just to help us see everything. So we've got our axes. I'm going to put a circle on that as well. Now, when you're doing this, you're going to be doing a sketch, so it doesn't actually matter as long as you've got things generally in the right places. So you can see here, I am trying my best to get this in the right place, but equally, it's not particularly important. Right, there we go. There's my circle. I'm just going to read the question because I've just remembered I haven't actually done that. It says, in this question, 1 centimetre equals 1 unit on the x-axis and 1 centimetre equals 1 unit on the y-axis. P is a point on the circle with centre OO, okay? So we've got a circle with centre OO, the origin, and we've got some point P. It says the coordinates of P are 8 minus 10. Now I've got no scale on this axis, but that's kind of deliberate so that I can just put the point P anywhere in a specific region, which I'm going to say in a second, but that could be correct, theoretically. Okay, so P, 8 minus 10, that's positive on the X, and then it's going to be negative on the Y. So let's just say it is somewhere down here. So let's say that's point P, and that is 8 minus 10. Okay. The line L is a tangent to the circle at the point P. L crosses the x-axis at the points Q and the y-axis at the point R. Work out the length of RQ. Now I'm going to do a line that goes through my axes and is tangent at the point P. So there we go, perfect. Scroll down so you can see how good that is. There we go. Not a bad sketch. Work out the length of RQ. Now it says crosses the x-axis at the point Q. So let's put that on. That's Q over here. But we don't know what that is. And then we've got R down here. But again, we don't know what that is. Now, once we've got that sketched, we can start thinking about the method. And before really you approach any question, especially one of these ones at the end of the paper, you want to thought about your method. Now, I know that a tangent is perpendicular to the radius. So if I put another line on here, going from the centre to that point P, which would be my radius, that is going to meet that line at 90 degrees. So we will have, don't know why I'm talking like that, we're going to have a 90-degree angle here. That's important because I know the gradient is going to be the negative reciprocal. And we know this is the origin here, OO. Work out the length of RQ. Now once we've got a diagram, I'm going to zoom this in so we can see it a little bit easier. Okay, what I need to do, my plan of attack, my approach, is to work out the gradient of the radius, then do the negative reciprocal. That will give me the gradient of the tangent. Then I'm going to use that with the point 8 minus 10, so the point P, to find the equation of that line. I've got the gradient, use that point to find the plus C. Then I'm going to substitute in x equals 0 and y equals 0 to get points R and Q. And then I'm going to use Pythagoras to find the length RQ, so the length between R and Q on that line. So that's the approach. Let's work through it. So gradient, let's just scroll this down slightly. That's too far. Gradient of, that is called O, it's the origin. So gradient of OP is equal to change in Y over change in X. So it doesn't matter which way around you do it, change in Y has to be on the top, change in X on the bottom, but it has to be consistent for change in Y and the change in X. What I mean by that is you have to subtract the numbers in the same order. So I'm going to have to get, well, I don't have to do it this way, but let me show you. So I'm going to go minus 10, so P take away O, so minus 10 take away O, Y take Y, over 8 take away O. So because I went with P for the Y coordinate first, I have to do P first for the X coordinate. Now that gives me minus 5 over 4. Okay, so that then means that the perpendicular gradient, so we could use the notation like this, do that a little bit better. This stands for perpendicular, M is your gradient, will be 4 over 5. What we are then going to do, hopefully you can see that, sorry I scrolled it just enough down so you could see the word gradient, but not actually the gradient part. Anyway, you can see that now, and I was talking you through it, so hopefully that was enough. Now we're going to use y equals mx plus c, so y equals 4/5 x plus c, and I'm going to use the point P. I can't use the origin because my line, my tangent, doesn't go through the origin. You have to use a point the line goes through. So I'm going to substitute my values in. So we're going to get minus 10 is equal to 4/5 of 8 plus c. Now 4/5 of 8 is going to give me 32 over 5. So I get minus 10. Just scroll that down a little bit more. Minus 10 is equal to 32 over 5 plus c. I'm going to take away from both sides here my 32 over 5. So I've got minus 10 minus 32 over 5, which gives me minus 82 over 5. So c is minus 82 over 5. That gives me, come over to the right hand side now, the equation as being y equals 4/5 x minus 82 over 5. Now I could, if I wanted to, times everything here by 5 to get rid of those denominators, and in some ways that might make it easier for the next bit, but only slightly easier. So what I'm going to do now, I've got the equation of that line. I need to find the points R and Q, so I need to substitute in x equals 0 to get point R. So x equals 0 for here, and y equals 0 for the point Q. So if x equals 0, we get that y is equal to minus 82 over 5. Okay, so this point here is minus 82 over 5. If y is equal to 0, then we get 0 is equal to 4/5 x minus 82 over 5. Add the 82 over 5 to to both sides. Scroll this down. 82 over 5 is equal to 4/5 x. Times both sides by 5, we get 82 is equal to 4x. Divide both sides by 4. 82 divided by 4 is 20.5. So we get that x is equal to 20.5. Go back up here. This is 20.5. And then what I've got, which is going to be a little bit more difficult to see now because I've kind of written over the top of it, is a right-angled triangle, which I can use Pythagoras with, where the width is going to be 20.5. The height is whatever 82 over 5 is as a decimal, 16.4. So we're then going to use, maybe I can, no, I can't draw this shape very easily because the only shape I've got on here is a triangle that looks like this, which is not what we want. So let me delete that. Okay, I'll do a sketch here. Okay, so that's got a width of 20.5 and it's got a height of 82 over 5, which is 16.4, not 62, 16.4. So we are going to use Pythagoras here. We are going to square both sides, add them together, square root, because we are working out the hypotenuse. So the answer is going to be found by doing this. So hopefully this gives us something nice, but I am quite confident because the numbers for the gradient and the plus c were quite nice numbers. So 16.4 squared plus 20.5 squared gives us an answer of 26.25. Let me check. Ah, good. It does say about rounding. Okay, so that tells me it's probably not going to be a nice whole number, which it isn't. So I get 26.3 to 3 significant figures. And that is our answer. Super. That's probably one of the hardest questions on the paper. There's quite involved that, but if you do a sketch, it's going to make everything a lot easier. Okay, next question is this one, which is quite a nice question, I think. I've had a look at this one earlier. Solid A is similar to solid B. That means there is a scale factor for the length, for the area, for the volume. Here is some information about solid A and solid B. Now we've got two exact numbers for the area, so we can work out the area scale factor. And actually what I want to do here is I want to go from solid B to solid A because that's going to give me a scale factor which hopefully isn't a fraction. It's going to be getting bigger. So let's work out that first of all. So we're going to do 7,776 divided by 486. That is going to give us, I believe, 16. Now, I'm going to write here LSF, that stands for length scale factor, ASF, area scale factor, and you can probably imagine what VSF stands for, volume scale factor. We have worked out the area scale factor, which is 16. Now, to get the length scale factor and the volume scale factor, well, we actually need to work out, first of all, the length scale factor. To get to that, we need to square root. So square root 16, we get the length scale factor as 4. To then get from the length scale factor to the volume scale factor, think about the units. You're going from centimetres to centimetres cubed. You need to cube it. 4 cubed is, should know that, well, I do know this off the top of my head, but as I'm recording this video, I don't want to risk it. 64. I don't want to say something stupid. 4 cubed is 64. Use your calculator. It's there to help you. Don't want to make any silly mistakes. And not like me on this video. Don't want to make any silly mistakes. So volume scale factor is 64. Now we need to use that next because we've got not values, we've got expressions for the volume of solid A and solid B, which we need to use with the scale factor to work out the value for X, which we can then use to work out the height of solid B, the length of solid B, using the length scale factor. So we are going to take the volume, I'm going to go with the smaller one, so 2x, 2 to the power of x plus 4, times by the volume scale factor, which is 64, is equal to 8 to the power of x. Now, here you may notice all of these numbers are powers of 2. And actually, even if you don't notice that, you can't really do anything with 2 to the power of x plus 4 in terms of changing the base easily, at least. It's going to be, yeah, not nice to deal with. So that is kind of a good indication that we are going to have to change the base for the other things, okay? So I'm going to have to change the base for the 64 and the 8 to the power of x. So 2 to the power of x plus 4 is going to stay the same. 64 is actually 2 to the power of 6. And 8 is 2 cubed, but I've got 2 cubed, which is 8 to the power of x. From there, I've got 2 to the power of x plus, now when you times, you're going to add your powers. That's the law of indices for multiplication. So 4 add 6 is 10. And on the right-hand side, the law of indices for powers, basically when you've got one inside and outside of a bracket, is to multiply them. So we get 2 to the power of 3x. Now, because we've got one thing on the left and the right with the same base, we can then equate the powers. Those powers must be the same. So x plus 10 has to be equal to 3x. We can then subtract x from both sides of that equation and get that 10 is equal to 2x. Divide both sides by 2 and we get x is equal to 5, which is nice. From there, I'm going to scroll back up to the question. 3 to the power of x, we know x is 5, so that is 3 to the power of 5. And we know that our scale factor, our length scale factor, is this way at least, timesing by 4. So going the other way is going to be divide by 4. So we need to do 3 to the power of 5 divided by 4. And it says give our answer as a decimal. It's going to be, I presume, a nice, well, I didn't say nice, a non-repeating or non-recurring, an exact decimal. Okay, so we've got 3 to the power of 5 divided by 4. And that gives us an answer of 60.75, an exact decimal. There we go. So that is our answer. Go to the answer line. Maybe it's on the next page. It is. We've got a lot of room for that one for some reason. 60.75. Okay. There you go. Right, last question, and actually this last question, I believe it's the last question, it is not too bad at all. It's simply a case of making sure that you know graph transformations. Okay, so we've got the curve with equation f of x equals 5x squared plus 9x plus 2 is transformed to the curve with equation g of x equals 5 brackets x plus 4 all squared plus 9 brackets x plus 4 plus 8 by the translation AB. Write down the value of A and the value of B. Now, what I want to do is think about what's happened to the x. The x has been changed to x plus 4, and actually the coefficients in front, the 5 and the 9, are the same. So that tells me that it's just replaced the x with x plus 4. So what's happened is we've got f of x plus 4, but just replacing the x with x plus 4 doesn't change this number at the end. So we've gone from plus 2 to plus 8. And we know it's a translation, so we know it's some kind of addition, subtraction, inside the bracket, outside the bracket. To get from 2 to 8, we've added 6 to the whole function. Now, once you've got it in that notation, as long as you've learnt the transformations, we know that this is going to be 4 to the left in the x direction. Okay, if it's inside the bracket, it does the opposite of what you expect. It's not going to add 4 to the x, it's going to take 4 away from our x coordinate. If it's outside the bracket, it acts in the way you would expect, but it affects the y. So this is going to go up by 6. Now, to put that in a vector format for our translation, left 4 is going to be minus 4 and up 6 is going to be positive 6 as B. Okay, so that's part A done. Pretty straightforward, like I say, for one of the final questions. And then we've got this question, which I will need to zoom out slightly more on so we can get the top bit in. There we go. Let's try and fit it all in. There we go. So the graph of y equals p cos brackets x plus q for the values of x greater than or equal to 0, less than or equal to 360 is drawn on the grid below. Given that p is greater than 0 and q is between 360 and 0, find the value of p and the value of q. So here, this relies on you knowing your cos graph and what that looks like, as well as your transformations. Now, the cos graph normally, I'm just going to do a quick sketch on this right-hand side, starts at 1, goes down, comes back up. Okay, so this endpoint's 360, the bottommost point is at 180, this crosses at 90 and crosses over here to 70, goes down to -1 and up to a height of 1. Now on here it goes up to a height of 3. Now remember, if it affects the y, i.e. if it's outside the bracket, it behaves in the way you would expect. So this, because it's gone up and down to 3, it's been stretched in the y direction by 3. This has got to be 3 cos, and then we've got x plus something. Now what's happened here is this point, which should be at 90, has gone back to 45, halfway between 0 and 90. That should be over here. Okay, and this point here should be at 180. Okay, so it's gone from 180 down to 135. So, to move it left, we need to do the opposite. So, moving it left would be minus 45. Opposite of that would be add 45. So, this needs to be plus 45 here. Okay, and we know Q is between 0 and 360. So, we know it has to be plus 45 and not any other value, because you could have 360 plus 45, because that would shift it all the way like one cycle, and then another 45, which would do the same thing, which is why we have got this restriction here. So that's it, 3 and 45, and that is the end of the paper. So thank you very much for watching. I hope this was useful. It's obviously a much longer video, but it's aimed at maybe or potentially a different viewer than the person who normally views my videos. Now there will be some overlap, of course, but I appreciate that some people that watch the videos on Monday won't want to watch this, and vice versa, and that's absolutely fine. But yeah, I thought it might be useful, and it's something I've done before. So if you've got this far, if you're still watching, thank you very much. I very much appreciate you liking this video, and put your comment, whatever you say, because that will help to boost the video in the algorithm. And if you're not already, subscribe to the channel, because I'm going to be uploading more of these in the run up to the exams. Like I say, thank you very much for watching. I'm aiming to get one of these out every Thursday, so I will see you next Thursday, hopefully, if everything goes to plan, for another one of these. But these are long videos, so I will do my best. Thank you. Have a great week. Bye-bye.